Hello, this is Mr. Henry, and welcome to lesson 6.5. In this lesson, we're going to start talking about absolute value and their use in equations and eventually into inequalities as well. Um, so the Get the Goof says, how do I solve absolute value equations? And the essential question says that. And the Get the Goof here is just a problem that we did before from the last lesson. So let's see how we did. We're supposed to graph both pieces here on the same number line. So x is less than 0. Well, this would be the less than, and less than 0 would be this way. X is greater than or equal to 2, so this should be a solid dot at 2, and we're shading greater than or to the right, all this stuff. Okay, so we got a couple vocab words here. First off, absolute value equation. You could probably guess it. It's an equation that has an absolute value in it. Pretty self-explanatory. Absolute value is the distance a number is from 0. Now this is like the actual, like, the teacher definition of what absolute value is. The definition most people remember, or the way that most people use it, is you remember the definition, make the number positive. That's how most people remember it. It's just whatever's inside the absolute value thingy. So if you had that, most people remember that that just equals 3. Whatever's inside here is equal to a positive. That's how most people remember it. But the teacher definition is it's the distance away from 0. And the final vocab word here is absolute deviation. Absolute deviation of a pair of numbers. So it says the absolute deviation of x and a given value. So they're always going to say, okay, the deviation is 5, and from a given value of 12. Here's a little formula that's used to find what that absolute deviation is. So it says x minus the given value, the absolute value of that, is the absolute deviation. Now, that absolute deviation stuff sounds like a big pain in the butt. When we get to it, you're going to see it's actually a very, very simple concept that looks ugly because of this equation. It's really not that bad to find. Okay, so let's go ahead and get started. So here we have, we want to solve a couple of these absolute value equations. Now, this x, we're trying to find out what this x could be. What value could I plug in here for x to make this stuff equal 7? Well, I could plug in a positive 7. So positive 7, if I take the absolute value of it, gives me a negative 7. But I could also plug in a negative 7. If I took the absolute value of negative 7, remember those definitions? One of them says, like, make the number positive. Well, the absolute value of this, if I would evaluate this, turns out to be positive 7, which is true. So this absolute value equation actually has two answers. If I plugged in a positive 7, that would equal 7. If I plugged in a negative 7, this would equal 7. Okay, what about letter B? What number could I take the absolute value of it and get a negative 4? So you should be thinking, you can't, because absolute values only make positive numbers. So there's no way we could take the absolute value of that and get a negative 4. Well, you're right. This has no solution. Absolute values cannot equal a negative. It cannot be done. It is impossible. Absolute values cannot be negative. Absolute value is a distance. You never measure distances in negatives. and it always makes a number positive. Whatever definition you want to use, it cannot be done. All right, so how about a problem or two for you to try, just to get ourselves warmed up here. Please do letters C and D right now. Pause the video, do them on your own. When you're ready to continue, hit play, and we'll go through them together. Okay, you should have found letter C. You have two answers again, kind of like letter A. The two answers are a positive 8, because the absolute value of positive 8 is 8, and a negative 8. The absolute value of negative 8 is a positive 8. So both of these numbers are answers. So you can say x equals that and that. Letter D, that's another one that's impossible. It has no solution because absolute value cannot equal negative. So there's no solution. Pretty easy? I think so. There's two more problems from the textbook I'd like you to try. This comes from page 390. It's number 1. I mean, there's one problem, but it has two parts. So solve this guy, so that's problem number 1, and that guy, that's problem number 2. Go ahead, pause the video, do it really quickly. When you're ready, hit play. We'll go through it together. All right, you should have found in this part A, x could equal a positive 3 and a negative 3. Both of those, if you take the absolute value, you get positive 3. For letter B here, x could equal a positive 15 and a negative 15. Hopefully you're seeing the pattern. Positive and negative, positive or negative. Both of them are possible answers that could work. Now these are all nice and easy. When it starts getting complicated is when you start having other stuff besides just an x on the inside. Like example 2. Now things get a little bit more weird, a little more complicated. So here's how this works. I'm going to show you the trick to it, and then I'll try to do my best to explain why we're doing the trick in a second. So here's what you do to solve this. What we're going to do is we're going to set this stuff here equal to a positive 8, but without the absolute value. Because this stuff inside here could equal a positive 8, right? If we found the answer to this and this stuff is equal to 8, the absolute value of it would equal 8. But this stuff inside of here could also equal a negative 8, because if I take the absolute value of negative 8, I would get a positive 8. So I set this stuff, x minus 3, also equal to a negative 8. I've got two separate problems. I'm going to solve them each independently. So I would, on this side, I'd add 3, x equals, these cancel, 8 plus 3 is 11. On this side, if I add 3, x equals a negative 5. Now, I'm saying that both of these are possible answers. I want to check this. So I'm going to do some work over here underneath letter B. This is not letter B. In fact, I'll move B out of the way for right now. I want to show you that both of these are solutions to that problem. So if I plugged in, let me write down the problem first. If I plugged in the 11 minus 3, I'm saying if I do this math, I'm going to get 8 equals 8. 11 minus 3 is 8. The absolute value of 8 is 8. So 11 worked as one of my solutions. Okay, let's see if that negative 5 thing works as well. So if I plug in a negative 5 here, negative 5 minus 3 is negative 8. The absolute value of negative 8 is a positive 8. It makes the number positive. So we got another solution. Okay, so that's proof that this method works. So a quick little recap on what we did. You set the stuff inside the absolute value, this stuff, equal to a positive this number, so a positive 8, and you set it equal to a negative 8. Let's check letter B. If you're a little confused, another example might help out. So letter B here. This stuff inside of here could equal a positive 5, and it could equal a negative 5. So what we do is we separate it into two separate problems. 2x minus 7, this stuff could be a positive 5, and we would be true. Or the 2x minus 7, this stuff, this could possibly equal a negative 5, because absolute value of negative 5 is 5, and it would work out that way. So now we just solve both problems. I'm going to add 7, 2x equals 12, divide by 2, cancel x equals 6. And on this side, add 7, 2x equals negative 2? No, positive 2. Divide by 2, cancel x equals 1. So if I plugged in a 6 here, this would work out. If I plugged in a 1 here, this would work out. Both 6 and 1 are solutions. They're both possible solutions. All right. There's one problem I'd like you to try. I've done A and B. I would like you to try letter C. Go ahead, pause the video, do as much as you can on your own. If you get stuck, maybe hit play for a couple seconds till I give you some hints or I show you a step or two. Then pause the video and try some more on your own. Go ahead, and when you're ready, hit play, and we'll go through it together. Okay, so let's see. Here's what you should have done. You should have taken a 3x plus 3 equals 12 and 3x plus 3 equals a negative 12. Then you solve each of these separately, so minus 3, giving you 3x equals 9. Divide by 3's, cancel x equals 3. And on the other side, you subtract 3. 3x equals a negative 15. Divide by 3 on both sides. These cancel. X equals a negative 5. And that's all there is to it. So you set the stuff inside the absolute value equal to a positive 12 and equal to a negative 12. Then you solve each problem separately. Okay. Now, let's see what happens if we have other stuff in the problem. So, just so we're not confusing, I'll put letter B back in a second. Here's letter A. Now we have the absolute value stuff. We also have this stuff is being multiplied by 3 and being subtracted by 5. Well, we cannot do the splitting like we did here. We split it into two separate problems. We cannot do that until the absolute value is by itself. So think of this absolute value area here as a box. I want to get that box, everything there, by itself. So we have to get rid of this times by 3. We have to get rid of this subtract by 5. Think of like solving an equation. Imagine I had the equation 3b, b stands for the box, minus 5 equals 4. What would I do to get this b by itself? Think about solving the equations. We would start by adding 5. These would cancel. 3b equals 9. Divide by 3, these cancel. b equals 3. Guess what we're going to do with the absolute value? We're going to do the exact same stuff. We're going to start by adding 5, These cancel. We get 3 times 2x minus 7 equals 9. We want to get the absolute value by itself, so we have to get rid of this times by 3. So we divide by 3. and we get 2x minus 7 equals 3. So what we've done is we now have this absolute value by itself, and we did that by solving like a regular equation, treating this absolute value stuff as our variable. Now, we can take this, separate it into two separate problems, and solve. So from here, we're going to say this is our 2x minus 7 equals 3, and our 2x minus 7 equals a negative 3. Solve each of them, so add 7, divide by 2, x equals 10. No, 5. No, yeah, 5. Over here, add 7, 2x equals 4, divide by 2, x equals 2. That was a lot of work for one problem, but that's what has to be done here. So to walk through the whole problem before we see letter B again, I'm just going to talk through it. We started by getting the absolute value piece by itself. So we treated that as our variable and solved. So we got rid of the add and subtract, got rid of the multiply and divide. Now the absolute value piece was by itself right here. Since it was by itself, we could then separate it into the two separate problems, one with a positive 3, one with a negative 3. Then we solved each of the problems, and we got our two separate answers. Okay? Now, I'm going to have to erase most of this. I'm going to erase all this stuff over here. And then try to move these guys under here. Okay, letter B. We need to start by getting the absolute value piece by itself. So think of this as your variable. It's being multiplied by something, it's being added by something. So if you follow the steps to solve an equation, you get rid of the add and subtract first. 18? Yeah. Then we divide by 6 to get rid of the multiply and divide. X plus 4 equals 3. Now, the absolute value piece is by itself. Now we can take this and separate it into the two separate problems. So we're going to take this and we're going to say we have an x plus 4 equals 3 and an x plus 4 equals a negative 3. And solve. Subtract 4 here, x equals negative 1. Subtract 4 here, x equals a negative 7. And those are our two answers. So get the absolute value by itself, separate it into your two separate problems, solve each of them. Done. Okay? Well, we've done A and B together. I would like you to do letter C, please. Go ahead, copy it down, do the problem on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, let's see how we did. Let's start by, we would subtract 3 on both sides. This is 20. Divide by 5, divide by 5. These cancel. Absolute value of 2x equals 4. Now the absolute value is by itself. Don't think of this, hopefully you don't have sloppy handwriting, think this is like 12x. Now, absolute value of 2x equals 4. Now we can take that and separate it into two separate problems. So we get 2x equals a positive 4, 2x equals a negative 4. Divide by 2 on both sides here, x equals 2. Divide by 2 on both sides here, and x equals negative 2. And we're done. All right. There are 3 problems from the textbook I would like you to try. These come from page 391, numbers 2 through 4. Go ahead, pause the video, do them right now, and we'll get back together in just a minute. Okay, number 2. The absolute value piece is already by itself. That means from here we can just separate into r minus 7 equals 9, r minus 7 equals a negative 9. Add 7, r equals 16. Add 7, r equals negative 2. Those are our 2 possible solutions for number 2. Number 3, the absolute value is not by itself. It's being added by 4.1, it's being multiplied by 2, so we solve this equation. So I'm going to start by subtracting 4.1, getting rid of the add and subtract first. 18.9 minus 4.1 is 14.8. Then we divide by 2, cancel. Absolute value of s equals 7.4. Then we take this and we separate it into 2 separate problems. Well, you get your s equals 7.4 and s equals negative 7.4. And those are our 2 answers. Because the s is already by itself, there's no math we have to do. And lastly, number 4 here. Let's solve it. So we're going to get the absolute value by itself. So we're going to start by adding 5. That gives us 4 times t plus 9 equals 24. Divide by 4 on both sides. These cancel. T plus 9 equals 6. Now the absolute value is by itself, so we can separate. We get t plus 9 equals 6, and a t plus 9 equals negative 6. Solve each independently, so I subtract 9 on both sides. T equals negative 3 here. Subtract 9 on both sides. T equals a negative, I'm out of space, 15 there. Negative 15. Yeah, we fit it. Okay, so that's really all there is to these problems. Now, there might be times where we get some strange things happening, but for the most part, that's the lesson. If you can do those 3 problems and you are successful, then you should have no problem with these absolute value things. Okay. Next, we have to decide if an equation has no solutions. Now you got to think, when would an equation have no solution? The only times we've seen today when a problem had no solution was at the very beginning, when we had things like, let me find the right slide, that one. When we had the absolute value was equal to a negative. And you're not allowed to have absolute values equal to a negative. So, as we're solving this next set of problems, if we get the absolute value stuff equals a negative, well then there cannot be a solution because absolute values cannot equal negatives. So let's see here. To get this absolute value stuff by itself, so think of it as our variable. There you go. So that stuff is being added to 6. So if we subtract 6, we get 3x plus 5 in the absolute values equals a negative 8. Can the absolute values by itself now, and can absolute value equal negative 8? No, it cannot be done. So this problem has no solution. Because absolute value cannot equal a negative. It can't be done. Absolute value cannot equal a negative. Letter B. Let's see. So if we add 9, again, we're getting the absolute value piece by itself. These cancel. We get absolute value of 2x plus 4 equals 14. So far, we're good. Absolute value equals a positive. We're good. We can solve this guy. We can do our math here. So we separate. 2x plus 4 equals 14, and 2x plus 4 equals a negative 14. Solve each. So I subtract 4 on both sides. 2x equals 10, divide by 2, divide by 2, x equals 5. On the other side, minus 4, 2x equals negative 18. Divide by 2 on both sides, and x equals a negative 9. All right. So, no solution if the absolute value equals a negative. Now, the absolute value has to be by itself first before you decide it's good or not. So here, please try letter C. See if it has a solution. Get the absolute value by itself first. If it does not have a solution, you write no solution. Go ahead, pause the video, and do that now. Okay, so let's see. We'd have to start by getting the absolute value by itself. So I'm going to get rid of this plus 8 by subtracting 8. These cancel. Absolute value of 2m minus 3 equals a negative 1. The absolute value is by itself equaling a negative. That cannot work. Absolute value cannot equal negative. So this problem has no solution. Absolute value cannot equal a negative. Okay. Two problems for you to try. It says solve the equation if possible, which means it might not be possible, but it might be. So solve these two if possible right now. Okay, so let's see how you did. In this first problem, number 5, you would start by getting the absolute value by itself, so we'd have to subtract 4 on both sides to get 2 times the absolute value of m minus 5 is equal to negative 2. Don't fret about this part being negative yet, because the absolute value is not by itself yet. So we divide both sides by 2. Absolute value of m minus 5 is equal to a negative 1. Now we can worry about it. The absolute value by itself is equal to a negative 1, which is no good. This problem has no solution. Okay, number 6. Everything looks negative, but let's just see how it plays out. So we start by adding 7. We get the negative 3 times the absolute value of n plus 2 equals a negative 3. Divide by 3, negative 3. Divide by negative 3, because we want to get rid of the negative and the 3, so those cancel. We get the absolute value of n plus 2 equals, a positive 1. So even though it started out with all those negatives, it ends up being equal to a positive 1, which means we can do this. Absolute value equal positive. Good. So now we separate it into the two separate problems and solve. So n plus 2 equals 1. N plus 2 equals negative 1. Minus 2 to solve. N equals negative 1 here. Minus 2 to solve. N equals negative 3 there. And we're done. Okay, so we had some good practice with this absolute value in the equation stuff. They will show up again in another lesson with inequalities, and we're going to see how, for the most part, it's the same. We got to do a little bit of funky stuff with the actual inequality symbol, but the solving is going to be the same. We get the absolute value by itself. We separate it into the two separate problems and then solve each of them separately. Now, absolute deviation. This was that one vocab word we had that I said it seems really complicated. I mean, the equation says it's the absolute value of x minus a given value is the absolute deviation. It seems really complicated, but it's really not. So look at the problem. It says if the absolute deviation from 9 is 5, what values satisfy this requirement? So what they're doing is they're giving us they want the absolute deviation is 5. The absolute deviation is 5. So we plug in a 5 for the absolute deviation. This given value is kind of like the middle. It's the number you're starting from. So what's the absolute deviation from 9? That's our given value. Now look at that. That problem, now that we've done all those other hard ones, this problem is actually pretty easy. The absolute value equals a positive, which is fine. So now all we do is we take this, I'm going to do it over here, we separate it into two separate problems. X minus 9 could equal a negative 5. Solve both of them. Plus 9 to solve. X equals a positive 4. So we got 14 and 4. Now, I want to give you a simpler way to think about these problems. A way you can check your answer, or sometimes even do them like this. So here's what this is really saying, this absolute deviation stuff. It's saying, imagine you have this number 9. There's 9. The absolute deviation is a change. If I went from this number 9 and I changed by 5 numbers this way and by 5 numbers this way, what numbers would I be at? Well, if I'm at 9 and I go 5 units bigger, 9, 10, 11, 12, 13, I'd be at 14. One of our answers. If I'm at 9 and I go 5 units smaller, 9, 8, 7, 6, 5, I'm at 4. So really what this is saying is this given value is the number in the middle, and the absolute deviation is how far you go up and how far you go down from that middle number. That's all it's saying. Now, if you have a hard time doing it in your head like this, well, that's why we have this little equation. Okay? The concept is really simple. The math behind it could be a little bit more complicated. Let's check out letter B. It says the absolute deviation from negative 2 is 6.1. So negative 2 is our middle number. So we have x minus negative 2. And it says the absolute deviation is 6.1. So if negative 2 is my middle number, if I go 6.1 that way and 6.1 that way, I will get my two solutions, whatever they are. Well, let's do it. This guy here, if I simplify, x minus a negative 2 is really just x plus 2. So I just simplified this a little bit. Separate. X plus 2 equals 6.1. X plus 2 equals a negative 6.1. Minus 2 to solve. X equals 6.1 minus 2 is 4.1. So if I'm at negative 2 and I go 6.1 this way, I get to 4.1. This other part, if I subtract 2, x equals negative 8.1. If I'm at negative 2 and I go 6.1 that way, 8.1. Those are my possible solutions. The given number is the number in the middle. The absolute deviation is how far you go bigger and smaller from that. That's all there is to it. And using the absolute deviation equation, x minus a given absolute value of that equals the absolute deviation. Please try letters C and D right now. When you're done, we're done for the day. Okay, it says if the absolute deviation from negative 8 is 2, what values satisfy this requirement? Well, we'll do it both ways. We'll do the equation way first. So x minus the given value equals 2. So again, this is actually a plus. So if I separate it, I get x plus, that's not a plus, x plus 8 equals 2, x plus 8 equals negative 2, subtract 8, x equals negative 6, subtract 8, x equals negative 10. So I got the answers of negative 6 and negative 10. Well, think about it. If you have negative 8 here in the middle, you go 2 this way and 2 that way. 2 bigger than negative 8 is negative 6. 2 smaller than negative 8 is negative 10. Those are the answers we got. So those are the numbers exactly 2 units away from this given number, this middle number. And letter D is a little wordy problem. It says if a pencil is normally 0.3 inches in diameter, but has an allowed deviation, so it's giving us a deviation, of 0.05 inches, what is the range of diameters a pencil could have? So this is the given number, the middle number, and it says it could go bigger by 0.05 or smaller by 0.05. So x minus the given value is the absolute deviation, and x minus 0.3, let's try that again, 0.3 equals 0.05, and x minus 0.3 equals a negative 0.05. Add 0.3 to both sides. These cancel. X equals 0.35. Don't believe me? Check it. 0.3, that didn't work. 0.3 plus 0.05, 0.35. Told you so. On the other side, if we add 0.3, these cancel. X equals, we're going to get a 2.95. No, not 2.95. What the heck am I thinking? 0.25? 0.3 minus 0.05. Yeah, 0.25. That'd be inches. Both of these have labels of inches. So this is using it this way. If we want to do this using the separating way, the 0.3 is in the middle. And if I get 0.05 bigger, which means we add those two, which is what we did here, or 0.05 smaller, which means you'd subtract it, that's what we did here, you get those two values. All right. So, if you could please answer me this question. It says, how do you solve absolute value equations? Give me an answer in your own words. What are the steps we went through when we solve these absolute value equations? Go ahead, pause the video, write down a summary right now. Hit play when you're ready. Okay, you should have said first, we want to get the absolute value by itself. So get the absolute value by itself. That's the very first thing we do. Once the absolute value is by itself, then we separate it into the absolute value equals the positive number and the absolute value equals the negative number. So I'm kind of abbreviating here, but it said then separate into absolute value equals a positive and absolute value equals a negative. Then solve each problem. Now your answer doesn't have to exactly match mine, but you should have had some of the same stuff. You had to say you had to get the absolute value by itself. You had to talk about separating it into both problems, and then you solve each of them. And then maybe both of those are your answers. You might have said something like, if the absolute value equals a negative, then it can't be done. You get no solution. All that kind of stuff. Okay, homework comes from page 393 from the textbook, numbers 10 through 16 even, and those couple other problems. So that's like what, 3 problems there, 4, 5, 6 problems total. That's pretty quick and easy. So this has been lesson 6.5. Thank you for watching.